We're going to begin the actual notes for section 9.1. We're going to start graphing quadratics in standard form. Now we should all know, just like we did on the class opener, we should all know where A is at, B is at, and C is at in a standard form quadratic trinomial function. Okay. Before we did not have an equation, we just had a standard form quadratic trinomial, and in chapter 8 we would factor it by multiplying A times C and thinking of the multiples of that answer and so on and so on. But right now we actually have a y equals right there, which makes it a function. And a function is like a machine. You could plug in inputs and you could get out outputs. And we did that on the class opener as well. We plugged in numbers into the inputs, which are the x values, and we did math and we got answers, which were the outputs, which are the y values. Up until this point, we've only graphed lines, y equals mx plus b, but today we're going to begin to graph parabolas. And parabolas, what are they? They are U-shaped curves. They either open up or down, okay? It's either a parabola opening up or a parabola opening down, okay? The most simple type of parabola would be the function y equals x squared. We can graph this function just like any other function by using an input-output table, an xy table. So we're going to graph the easiest type of parabola, the most easy parabola there is. And actually this parabola is called the parent graph. But for right now, let's do what we would normally do to graph any type of function. Let's do a quick input-output table. Everybody do a xy table right here. And let's plug in some easy numbers. Could somebody give me a number to plug in?
4, 7, 0.
4. Okay, now let's. If I did plug in a 4, I already know. I want to put it way down here. If I plug in a 4 and I'm plugging it into my x's, right? So here's my x. What's 4 squared? What's 4 squared? 16. So if I did plug in a 4, I get out a 16. And ladies and gentlemen, that's a coordinate. But on this graph, if I go 1, 2, 3, 4 on the x and 16 on the y, I'm going to be way up here off the graph. So 4 was not the best number to pick here, right? 3, that's a better one to pick. If I do plug in a 3, what would I get out? 9. Okay, what else could I plug in? 2. If I plug in a 2, what do I get out? 4. If I plug in a 1, what do I get out? A 1. If I plug in a 0, what do I get out? 0. What if I go negatives, like plug in a negative 1, what do I get out? Now remember, when you plug in a number, you got to plug it in with parentheses. So maybe I should show this work. When I plug in negative 1 right in here, it's going to look like this. It's going to, instead of x squared, you're going to have parentheses squared. And when you plug in the negative 1 right in there, that's obviously going to be a positive 1. So you also get the output of 1. If I plug in negative 2 in parentheses squared also gives you a positive 4. A negative 3 in there in parentheses squared will also give you a positive 9. So let's check out how this works out. The coordinate 0, 0, that's going to be the origin. It's right there. And if we go to the coordinate 1, 1, that's going to be 1 on the x, 1 on the y. We put a dot right there. And if we go to the coordinate 2, 4, 2 on the x, 1, 2, 3, 4 on the y, it would be right there. And this last one, 3, 9, it would be way up here. Now, if I went for the negatives, check this out. I want to do the negatives in green. Negative 1 and 1. If I go negative 1 on the x and 1 on the y, it'll be right here. If I go negative 2 and positive 4, it'll be right here. If I go negative 3 and positive 9, it'll be right here. What could you guys tell me about those blue dots compared to those green dots? They're at the same y level, but they're on the other side. It's being reflected on the other side, right? Now, the most important point on any parabola is going to be the highest point or the lowest point. In this case, it's the lowest point. That point's called the vertex. We'll get to that in a little while. Let me actually graph this parabola. Let me connect these dots. But what you were saying is absolutely 100% true about the coordinates. They're at the same y level, just opposite x values, right? There is a perfect reflection from this blue dot to this green dot through the vertical line that goes right through the most important point, the lowest point, which is called the vertex. So we're going to start labeling the lowest point or the highest point. We're going to label that as a vertex. So this red dot right here, let me just say vertex. Vertex. That's that red dot right there. It's either the lowest point or the highest point. If you had a parabola going up like this, then your vertex would be up here. It would be the highest point, right? It depends if your parabola is opening up or opening down. Okay, so this one's obviously opening up. So the vertex is the lowest point. That's the vertex. A vertex is a coordinate. In this case, the vertex is the coordinate 0, 0. Through the vertex, there's a vertical line, and we're going to call that vertical line the axis of symmetry. So I'm going to draw a dotted line going right through the vertex. It's going right through, up and down, right through the vertex. That's called the axis of symmetry. Axis of symmetry. Why? Because it provides symmetry. It provides a reflection from one side of it to the other side. So this blue dot, it's 1 unit away from that green vertical line. So the green dot has to be 1 unit away. This one is 2 units away. So this one has to be 2 units away. This is 3 units away, which means that this one has to be 3 units away. Now, knowing the axis of symmetry and how it provides a reflection will save you a whole lot of time. You're not going to have to do this whole ginormous XY table and plug in all these different numbers. You're going to be able to plug in a couple of numbers and then just map them over to the other side, and you'll have your entire parabola very quickly. So I hope you guys took notes and did everything I did right here. And let's move on. It says, as you can see, when you plug in negative numbers, you still get positive answers, because when you square a negative number, you'll get a positive answer. Let's talk about the vertex. The vertex is a coordinate. A coordinate is an x and y value. Let's understand that. Let's pause right there. A vertex is a coordinate. That's a coordinate right there. It has an x value and it has a y value. It's a location. It's the highest point or the lowest point of your parabola. That's what it says here. It's the highest point or the lowest point of your parabola, depending on whether it opens up or down. So on this first one that we did, it opened up. It opened up. So the vertex is the lowest point right here. That's the vertex. And that location, it's a coordinate. What's the coordinate? In this case, it's 0, 0. It's not always going to be 0, 0. You might have a vertex, like let's say right here, and maybe your parabola is opening down. And that coordinate would not be 0, 0 anymore. This coordinate would be negative 5 or 6, negative 1. So that coordinate for the vertex would be negative 6, negative 1. Anyways, you don't have to draw that. But my point is, the vertex will not always be 0, 0. The vertex is a coordinate. It depends where your parabola is at. The highest or the lowest point, that's your vertex. Okay, now, here's another interesting fact. If the A value is positive, it opens up. If the A value is negative, it opens down. Okay? What am I talking about, A values? If you have a standard form quadratic trinomial, if the A value, if the number out here in the front of the x squared, if it's positive, it's going to open up. The parabola is going to be a U-shaped curve opening up. If the A value is negative, it's going to be opening down the parabola. These are important facts that we need to know. It'll help us on the final exam, because if you know these facts, you'll be able to eliminate certain multiple choice answers. Okay. You know what? Maybe I should pause right here and give you a visual with regards to the A value. So we're going to start with the A value of 1 being a regular U-shaped curve. Okay, so check this out. Here's your regular A value of 1, right? If you have y equals x squared, the A value of 1 is a regular U-shaped curve, right? Now, if your A value changes to the value of 2, like let's say instead of y equals x squared, you have y equals 2x squared, that'll actually make it stretch more. If you go y equals 3x squared, makes it stretch more. Y equals 4x squared, 5x squared, right? So the bigger your A value is, the more stretched, the more narrow the parabola gets. So the regular A value of 1, here it is. Now if I take that A value and make the A value of 1 become the A value of 1/2. So if I had the equation y equals 1/2 x squared, what do you think would happen to the parabola? If I went from a regular A value of 1 to an A value of half, what do you think would happen? Makes it wider. Wider, right? So here's a regular A value of 1. If I have y equals x squared, here it is. But if I have y equals 1/2 x squared, it gets wider. What if I go y equals 1/5 x squared, even wider? What if I had y equals 1/10 x squared, wider? What if I had y equals 1/100 x squared? It's almost flat because 1/100 is almost nothing, right? I mean, it'll look like a flat line, but it does curve a little. If I actually got to 0, it would be a flat line. It wouldn't be a quadratic anymore. It wouldn't be a parabola anymore. It would be a flat line. Okay, so once again, the a value of 1, regular U-shaped curve, right? A value of 2, 3, 4 gets narrower. But if you get the regular a value of 1 and you make it smaller, closer to 0, like y equals 1/2 a squared, it get wider. Y 1/10 a squared, wider. Okay? Now, once again, here's your a value of 1. If I have the a value of -1, y equals -1 x squared. All right, the a value is -1. What's going to happen is it's going to reflect, it's going to open down instead of up. Okay? So y equals -1/2 x squared is right here. Y equals, not 1/2. Y equals -1 x squared is right here. Y equals -1/2, it would get wider. Y equals -1/10, it'd get wider. Okay? So the a value, if it's positive, it opens up. If it's negative, it opens down. The closer it is to 0, the wider it gets. If it actually became 0, it would be totally flat. The closer it gets away from 0, the more narrow it gets, the more vertically stretched the parabola gets. Does that kind of make sense? Yeah. Okay, cool. You want to pause that for me? Thank you. Thank you. So you're definitely, whoops, I was still recording. Anyway, we're going to keep going. You're definitely going to use all these skills in Algebra 2, but just knowing the a value will even help you eliminate certain questions on the final exam. Just by knowing if the a value is positive, it opens up. If it's negative, it opens down. Okay, let's move back to the vertex. The vertex is the most important point on a parabola. It's the highest point or the lowest point of a parabola, depending on whether it opens up or down. Now, we do have a formula we're going to learn today. We have to memorize eventually at some point. It's the vertex formula. Now, the vertex formula is this: x equals -b over 2a. And as a matter of fact, I already had you practice this on the class opener. Okay. Now, we said that the vertex is actually a coordinate. It's an x value and a y value. It's a location on the xy plane. It is the highest point or the lowest point of a U-shaped curve, depending if it opens up or down. It's the most important point because right through that point, right through the vertex, exists the axis of symmetry, right? The vertex, the most important point, the lowest point, right through it is a vertical line, the axis of symmetry, which provides a reflection, right? So the vertex is super important. Now, this formula that we have to memorize says x equals, and we know that the vertex is an x and a y value, okay? So this formula only gives us the x value, and once we have the x value, whether it's a 2 or a 5 or a -1, whenever you have the x value, to find the y value, all you have to do is plug it back in to the original equation to find the y value. It's like having this as an input and finding the output by doing the math. So the best way to understand this stuff is to get right into it and do a practice problem. Let's just jump right to this one right here. So what's the most important point on any parabola? The vertex. How about this? After watching what I just did, is this parabola, this is going to be a U-shaped curve. How do I know that? Because it's an x squared. It's going to be a U-shaped curve. Is this U-shaped curve going to open up or down? Down, because it's negative, right? Now, is this going to be a wide parabola or is it going to be kind of narrow? Remember, the closer you get to 0, the wider it gets. The further away you get from 0, the more narrow it gets. So this is going to be pretty narrow because it has an a value of -3, right? This guy over here on the opener, on the the parent graph, it's a regular U-shaped curve. Why is it regular? Why is it not too wide? Why is it not too narrow? Because the a value is 1. If you went to 1/2, it would get wider. If you went to negative, it'd just be the same width, but just opening down. So y equals negative x squared would be opening down. Y equals -3 is going to be very narrow, opening down. So let's go back to this guy. You already know that it should be narrow and it should be opening down. But let's start by finding that most important point, which you guys just told me was the vertex. So let me go over here to the side, and I hope you guys do this as well. Write down vertex and do a coordinate, because the vertex is a coordinate. And we do know that the vertex coordinate has an x value and it has a y value. And we should have the formula memorized. What's the formula? X equals -b over 2 times a. So could somebody look at the standard form quadratic trinomial and tell me the a, b, and c values? What's the a value on the standard form? A value is -3, b value is 6, c value is 5. So ladies and gentlemen, this formula will give me the x value. X equals -b over 2 times a. And what is my b value? 6. What's my a value? -3. So when I plug in the 6 and the -3 and I do the math, I'm going to end up with a -6 up on top and a -6 on the bottom. And what is -6 divided by -6? +1. So what did we just find right here? What did we just find? What does this say? It says x equals 1. We found the x value of the vertex. Remember, the vertex is a coordinate, an x and a y value. So far, we found the x value, which is 1. We still need the y value. So how do I find the y value? By plugging in the 1. Where am I going to plug in the 1? Into my x's. 1 is my x. Plug it into your x right there, and plug it into your x right there, and do the math. So let me take this function right here, and let me rewrite it. Y equals -3 times x squared plus 6 times x plus the c value 5. And let me plug in the x value of 1 into the parentheses to replace the x's that used to be there. And now let's do the math. Exponents first. 1 squared is 1. And you really have a multiplication, -3 times 1. What's -3 times 1 right there? -3. And how about 6 times 1? What's 6 times 1? 6. And then bring down that plus 5. So doing the math, we're going to have -3 plus 6. What's -3 plus 6? Anybody awake? 3. And 3 plus 5? 8. So we just found the y value. Y equals 8. The y value of our vertex. So our vertex is 1, 8. That is the most important point. Let's graph that most important point. 1 on the x and 8 on the y. Let's put a dot right there. 1, 8. That is our vertex. It's the most important point. Why? Because either the highest point or the lowest point of your parabola. Not only that, right through that point is a vertical line, and that's called the axis of symmetry, which will provide us with the reflection on both sides. All right? So we have the most important point. We still need some more points. How could I find more points? Back when we did lines, how did we find points? With an XY table. So let's plug in some points. What number would you like to plug in? Now, here's the deal, guys, before you give me numbers. You want to plug in values that are close to the vertex x value. Okay, now, it would be pointless to plug in a 1 for x. Why is that? Because you already plugged in a 1 and you got out an 8. So if you plug in a 1 again, you're going to get out an 8 again. That'd be dumb. You already did that, right? So what other number would be easy to plug in? What's the easiest number to plug in? 0. So check this out. I am going to plug in a 0. And when I do plug in a 0 right there, 0 squared is 0. -3 times 0 is 0. 6 times 0 is 0. 0 plus 0 is 0. 0 plus 5. What's 0 plus 5? 5. So for my input 0, I got an output of 5. Now, if I graph that point, 0 on the x, 1, 2, 3, 4, 5 on the y, there it is. Are you with me? Now, the beauty of knowing the most important point, the vertex, and knowing that the axis of symmetry goes right through it, is that once you find a point, you could just map it over to the other side. Right here, it's 1 unit away, map it over 1 unit away, and you will end up right here. So you need, let's plug in one more point. So which other number would you like to plug in? You already plugged in 0, that was easy. Do you want to plug in 1? No. Why? Because we already plugged in 1. Do you want to plug in a 2? No. You know why? Because if you plug in 2, 1, 2, you're going to get the output 5. I already know that because I already found that out by reflecting it to the other side. So plug in a 3 or a -1, whatever you want. It's up to you. You guys want to plug in a 3 or a -1? 3. You can do -1 if you want, but if I plug in a 3, let me actually show the work here. I'm going to have -3 squared, or x squared plus 6 times 3 plus 5. And let me plug in this input of 3 right there and right there. You could do this with the calculator. 3 squared is 9. 9 times -3 is -27. -27 plus 18, I better use a calculator here. -27 plus 18, and then plus 5 at the very end on the calculator gives me the output -4. So for my input 3, I get the output -4. That's a coordinate 3 on the x, -4 on the y. So from the origin, 3 on the x, 1, 2, 3, -1, 2, 3, 4. And I would put a dot right there. And of course, I could map it over to the other side of my reflection line, my axis of symmetry. It's 2 units away. Go 2 units away this way, and you'll get that dot right there. And ladies and gentlemen, that is a perfect graph of the parabola y equals -3x squared plus 6x plus 5. Notice it's pretty narrow because the a value is -3. It opened down because it's negative. The vertex is definitely not at the origin, it's somewhere else. So that's how we graph. It's a long process, but the more you practice, the faster you're going to get. And you could use the reflection. And when your a value is 1, you're going to get this beautiful situation that you're going to be able to use a certain pattern. But I'll go over that on the next video. Right now, we're going to stop here and we'll pick it up on this next one on the next video.